parametric equations, and let's remember what we have talked about before. Remember, we have y as a function of x. So this is in your past. You've done all this stuff. Y is a function of x. Y prime is we can call it f prime of x. We can also call it dy dx. And then when we get to y double prime, one of the concepts here that we're going to get to in parametric, I want to just show you how it's related to what you already know. Y double prime is the derivative of the derivative. Okay, so the derivative of the derivative of y with respect to x, and that's kind of bulky, so that's not something we see a lot. Normally we see it written like this, with a little 2 in between the d and the y, and then with a little 2 after the x. And one student asked me today, Mr. Huck, where did that extra x go? Notice there's 2 x's here, there's 2 d's, and basically the second derivative is the derivative of the first derivative. If you can just keep that in mind, then really this concept, applying it to parametric, becomes actually pretty easy. But let's go ahead and title this next box parametric, just parametric, how about that? So I was trying to think of something fancy, but that's good enough. Parametric. And we still have y as, well, now, so y is a function of t, and I should have started with x. X is also a function of t, but we still are desiring to find dy dx. Now let's just pause here for a second. Let's keep in mind, what is dy dx? Well, dy dx, you have this curve, like that bug walking around your paper. You have a curve and you've got a tangent to that curve, and the tangent line to that curve, it doesn't matter how the curve is expressed, the tangent still has a slope to it. So we have slopes, right? We've got a slope of the tangent line at any point. Now again, this curve may have been mapped out by x equals, I have g of t down there, so I'll keep that consistent, and y equals f of t. So it might have been mapped out using the parametric equations. Nevertheless, you still have a tangent line to the curve, and you can have a slope of the tangent line. Every line has a slope except vertical lines, and we'll get to that as well. So the dy dx, we have to get the parametric because y depends on t and so does x. And so you might remember from your pre-calc honors days that your dy dx is actually equal to dy dt over dx dt. Now that's really important. Okay, that's your y prime. All right, and then let's get to the second derivative. Okay, so your y prime is that. Your second derivative is written like this, and I just wanted to point out here, this guy right here is your dy dx. Okay, well, the second derivative is just the derivative of the first derivative. Okay, so let's keep that in mind. The derivative of the first derivative, dy dx, with respect to t over dx dt. Okay, if you look over here, compare, the second derivative is equal to the derivative of the first derivative divided by dx. Okay, well, this y over here in the parametric side, this y and this x both depend on t. So we take the derivative of the first derivative with respect to t, divide that by the derivative of x with respect to t. And this right here, guys, this is your bread and butter, and you need to make sure you remember this. This is very important to remember. I'll put 2 stars in the upper right corner, so that makes it really important. Okay, so let's go ahead and do a couple examples, and let's see how it works. Let's cruise on down here to this box. Let's see if I can keep that in that spot right there so you can see it still. So your example 1 will be let x, we're going to define some parametric equations. Let x equal t squared plus t. A lot of t's and plus signs in here, so I put a little curve to my t's there. Y equals t squared minus t. Okay, so the first box we're going to find dy dx. Okay, I'm going to give you a couple of suggestions, and I hope you use them because students have a tendency to make mistakes when they don't follow exactly what I say you need to do. Okay, dy dx is defined to be dy dt or dx dt when the equations are given parametrically, And dy dt, let's do that right underneath. In fact, let's do that in green. Dy dt is 2t minus 1. Dx dt, and all I'm doing is taking the derivative of these parametric equations up here with respect to t. So the derivative of x will be 2t plus 1. Okay, now if you don't write this out, then you're going to have a tendency to take the derivative of the first and then divide it by the derivative of the second. So that's not the case. Dy dt, it shows us, is 2t minus 1, and dx dt is 2t plus 1. Okay, pretty simple. There's our dy dx. Just to reiterate, I know you see it over here, but again, some students forget. They get this middle thing here and they forget that that's their dy dx. Okay, so the second part here is find the second derivative of y with respect to x. Okay, so we already have our dy dx right there, and we know what the second derivative is. The second derivative of y with respect to x is equal to, right up there, the derivative of dy dx with respect to t, divide that by the dx dt. Okay, and what's the derivative of the dy dx? Well, we see the dy dx right here. Okay, so now I can scoot it up because we already have the formula. We see the dy dx here, and what's the derivative of this quotient with respect to t? Okay, well, the derivative of the quotient, we have to use the quotient rule. Low d high, low, which is 2t plus 1, d high, derivative of the high, of the numerator is 2, minus high, which is 2t minus 1, d low, derivative of the denominator is 2, over low squared, okay, 2t plus 1 squared. And now I could put divided by, and I could put all the big line here, divided by dx dt. We already know that dx dt is right over here. Okay, so we're going to have to divide that whole thing by 2t plus 1. Okay, but I'm going to write it like this, divided by 2t plus 1. Okay, in parentheses. So that is what we're dividing by. That's our dx dt, and that has to be what we're dividing by. Okay, so don't forget that. Muy important. All right, and then let's go ahead and simplify the numerator. We have 4t plus 2, 4t plus 2 minus 4t minus 2, 4t minus 2 over, and this is like, okay, so we have 2t plus 1, and then if you think about this, this is like multiplying by 1 over 2t plus 1. Okay, so cross that out, multiply by 1 over 2t plus 1. So really we have, instead of just 2t plus 1s down there, we have 3 of them. Okay, and if we simplify the numerator, you can get 4 t's canceling out, and we get 2 minus negative 2 is 4 over 2t plus 1 cubed. That's good for at least one problem on your AP exam. For sure one problem on the Chapter 10 test. Okay, so keep that in mind. Many students just forget about that dividing by that dx dt. So don't forget that. Okay, example 2. All right, so you didn't get the warm-up like the period 5 class did. Let's move right on down here and let's see if we can tackle example 2. And what we're going to try to do here, let's try to put this all in one video here. And in saying that, you know, I'm looking at the time here, 9 minutes. Let's go ahead and break that down, and I will start example 2 in the next video.